Yeah.
Hello, Mr. Aaron, Mr. Ryan, all right?
No.
You're not right? So how can I make you better? Let's look at this, okay? So we're given a grid with cells, and then this is football, or volleyball, or ping pong ball, or whatever ball, okay? We put it in one of the cells. And then for each move...
How can,
Yes?
never mind.
Okay, so at each step, you are allowed to move the ball horizontally, left, right, or vertically, up, down, okay? And you're given n, which is that the maximum number of moves you can do to the ball, okay? So for example, n equals 2, say, okay, you can move the ball twice, at most twice. And the question, yes?
So you can move,
You can't move up or
you
left.
can't, so like you can make 0 moves.
Good question. 0 moves, yes, you're allowed. At most, n moves, right? You know, smaller or equal than n, right? You're making the moves, okay?
Okay, so you can't go up or left.
You can go up, down, left, right.
So that means there's 3 points. You could go in the loop. So
Yeah, that's good. Yes, you can go in the loop, of course. But the question, I haven't talked about the question yet, but the constraint
yeah,
is that
well,
at
that
most
one
n
is
moves.
not 2. You could go down, right, up. That's 3.
It's the amount of moves you.
You can move. For example, this one, 2 moves.
So,
You can do 2 moves, right? Let's take a look at one move. Okay, so one move you can do this: up, down, left, right. Okay, this is one move. And how many moves you move the ball out of the boundary, move it out of the grid?
2.
2. Yeah, obviously this one. Okay. Okay. Let's look at that
That's a
situation when we move twice.
Yeah,
When we
but
make
then
it
you
two.
could go in a loop and stay for as long as you want until you decide to
Okay.
go
Okay.
out.
So let's
And that's not fair.
Let's look at this. When we make 2 moves, 1, 2, 1, 2, 1, 2, and then what else?
You can go right and then left. And then it'll be loop.
Yeah, right, left. Okay, and then down. This one, down. Yeah. So here. Okay. So once you are outside, you cannot make any moves anymore. But for this one, if we make 2 moves, how many of them are out
You
of
can
the
use
boundary?
move right though. You can move right for the bottom one. You can move right.
Yeah. Okay. So how
So
many? 1, 2, 3, 4, 5, 6. Okay. That's the situation. So when we make at most 2 moves,
How
there are
about the
only
one there?
6
How about the square at the bottom right? You could also move there.
square at the bottom. This one.
Yeah.
Yeah, move that, but it's inside the grid. It's not outside the grid.
Yeah, you can move there and then move out.
No,
Yeah,
you 2 moves. You use 2 moves. At most 2 moves. Okay. Let's take a look at when we're about to make 3 moves. If we make 1 move, what happened?
Yeah. Go left, right.
Yeah, this one. There are only 2, right? 2. If we make 2 moves, 1, 2, 1, 2, 1, 2, yeah? 1, 2, 1. Okay, so that's 2 moves,
You
right?
can go left and then go right.
Yeah. Left and right, okay? But this inside, right? Right or left is inside, so we don't count that. So then we add 1, 2, 3, 4, 5, 6. We only count when we move the ball outside, okay? If 3 moves,
You go left, right, up.
yes, okay? So left, right, up. Left, right, down, right? Or right, left, up. Right, left, down. Right? So that's how many? 4, right? So all together 12. Okay, return 12. This one return 6. Interesting?
No.
Not interesting?
Yes.
Okay, so any idea? So just give me any idea. Any keywords would be fine.
Brute force.
Brute force, yes, brute force. So how can we brute force? Or
Check every
simulation.
single possibility.
Check possibilities of moving every path, right? Check possibilities. So this problem is well defined, and we are given that n, meaning that we perform n steps maximum. right? So we can define a recursive function with n. So at each point, we're given the position of the cell or the ball, okay? We're given the position of the cell, and then with n step. So at this point, how many possibilities we can move? We can try move 4 directions, right? We can try move four directions and decrement the steps remaining. And once it's outside, we know we have one more path. If we run out of the steps, and if it's inside the grid, we return 0 because this is not a valid path. Okay? Otherwise, we just try 4 directions. Alright? Simple, right? This is the intuitive way. Right? Recursion. Are we clear on this?
No. It's boring.
So we want
I'm
to
not
count.
clear why it's interesting.
Define f. We have currently n steps remaining. We currently at position R and C. If the current R, if it's outer boundary, right? If it's smaller than 0, this is the row, right? Row number. This is a column. Which column is it? If it's smaller than 0, right? If it's outer boundary. If it's here, or if it's bigger or equal than the rows, the number of rows, or C is smaller than 0, so it's here, or column is bigger than the columns, then we return 0, right? Return 1, right? Because we have found a path out of the boundary. Then we check. At this point, it's inside the boundary, right? It's inside the boundary. If n equals 0, if we run out of the steps, then we return 0. Because if we run out of a step, it's still inside the grid. If it's still inside the grid, we return 0, right? Now, let's say the ball is here. This is the location, RC is here. So it has 4 directions, right? We can just try 4 directions. F, n minus 1, R minus 1, C. Plus, can you tell the rest? F, n minus 1, R plus 1, C. Plus, okay, so what else? F, come on. This is up, this is down. Okay, so what else?
N minus 1.
Yeah? What's this?
R.
And then?
C plus 1.
C plus 1 is this one, yeah? Okay, and then plus, what's next?
Computer.
N minus 1.
Yeah?
R. C minus 1.
Well done. Excellent. This is the 4 directions, yeah? This is just 4 directions. Recursive function. N minus 1. Why n minus 1?
Because it's deducting the amount of moves.
The amount of moves, yeah, we have consumed 1 more move. And then these are the 4 directions. Up, down, left, right? And then if it's out of boundary, we have found 1 path. If it's inside the boundary, however, we have used all the steps, then we return 0. Otherwise, we recursively call this function. This is the brute force, right? If we explore this as a tree, F, N, R, C, each node has spawned up to 4 kids, right? 4 kids. And then each tree has 4 kids. We call this core tree, right? Core tree. So each tree has 4 kids. And then some nodes will be intermediate. So the some nodes will be visited many times. This is brute force. This is a disadvantage of brute force, right? Okay. It's similarly like Fibonacci tree, right? Fibonacci. Remember, when we talk about Fibonacci, we talk about this same problem, similar problem. So what's missing here? This is brute force. How can we make it more efficient? So the time complexity for this one, right? For each tree, each node has 4 kids. So the time complexity is O 4 to the power of n, right? Because this is the branching factor. Okay, 4 kids. And the space complexity is On because the tree can go up to n steps. How can we make it more efficient? What's missing? Cache. If we have a cache, we save the state, so we make it a top-down dynamic programming, which is also recursion with memoization, right? Recursion with memoization. So basically, we save the state. So after saving the state, so for each NRC combination, we only compute once. Okay, so the time complexity for this one is O n times the rows times the columns. Okay, the space complexity is also O(n) times the rows times columns. Okay, because we need this amount of memory to store, to memorize, to minimize all the states, which is the combination of n times r times c. Okay, so similar to Fibonacci number. What have you learned today? Come on, can you describe the problem? Come on, let's see. Can you describe the problem?
We just do stuff.
What stuff? Come on, please.
You have this kind of thing,
Okay, can you explain the
Grid.
problem?
and
Yeah.
then you have this.
Grid, and there's a ball, and you want
Yeah.
to in normal moves of m, how much trees can you get off the grid?
That's excellent. Okay, that's very concise. Okay, so can you?
But I mean, if you get a dog,
We just
brute force.
since it's the amount of moves and then
Yeah.
just
Move
and
it.
we check how much ways are they to get off the grid with one move, and
Yeah.
then you do that, and then you do it with two moves, and then you do it till n, and then you add them all together.
Yeah, well done. Okay, so we use the recursion with the minimization, right, to speed up the computation. Okay, so we can also do this using bottom up. Okay, so okay, that's it for today. Bye bye. Bye bye.